So where we left off at, right? We were talking about VLAN concepts. We were talking about, and I spoke to you guys about communication between different switches, right? And then, of course, we were also talking about the concept of untagged and tagged. And I told you guys we were going to have a separate lab about that because the CCNA doesn't really cover the terms tagged and untagged and the concept of it, right? It talks about it, but it's more so of reading between the lines, right? Um, One thing, and I'm looking at my notes here. One other thing that we covered is VLAN tagging concepts, and I made sure that I explained to you guys that from an endpoint perspective, right? The control plane on the switch does not tag all the traffic, right? From ports that are in a specific VLAN. All it does is puts that port within that broadcast domain. Okay. The only time a switch is going to tag traffic is if it needs to do inter-switch communication, if it needs to speak to another switch, right? Because then it needs to say, okay, this broadcast domain extends over, right? Extends beyond this switch, right? And I have a trunk configured. I need to go ahead and say, hey, this is for this broadcast domain. This is for that broadcast domain. But you guys have to remember, tagging doesn't happen on traffic that is ingressing the switch, okay, or within the switch. So if there was no connection to another switch, and more specifically, 802.1q is not configured on that switch on any of the ports, no tagging is happening. All that's happening is that each port is going to be put in a specific broadcast domain based on how you configure it. Okay? So I need you guys to understand that difference. Tagging only happens, right? The 802.1q frame is only going to be seen, right? Only if you're only during inter switch communication. Okay? All right. We spoke about like I said, we talked about the IEEE 802.1q. We also talked about ISL, right? You guys won't be tested on ISL. But you guys will be tested on 802.1q, and you guys will be tested on the concept of native VLAN. Okay, we spoke about how native VLAN works. We spoke about, of course, some of the notes that were in that chapter. Let's go ahead and we need to speak about forwarding data between VLANs, right? Of course, we need to add some configuration. So first thing, like I told you guys, before we do anything and before we make changes to our lab, we need to go ahead and check our configuration, right? So I'm going to go on switch one and let's get a sense of our topology, okay? Let's do a show run, right? And let's take a look at what our topology looks like, okay? So we have spanning tree configured, right? All right, and we have our ports, okay? None of them are in specific VLANs, okay? Yeah, we have none of them in specific VLANs. All right. And just to be sure, right, we trust but verify. Let's do a show VLAN. Okay. All right. Excellent. So this is old code. So I want to take my word back. So I do apologize. We did configure, right? Two ports, right? We got one port, right, in VLAN 10, which is, of course, the sales VLAN. And we have one port, right, gigabit 0/2, in the engineering VLAN, right, in VLAN 20, right? Let's go ahead and take it a step further. Let's see if we have a trunk configured. Okay, let's do a show interface trunk. Okay, so after putting in that show interface trunk, nothing popped up, right? So that's telling me, right? And of course, it matches up with all the interfaces that I have, right? I don't see an interface missing that tells me, especially gigabit 0/0. This is telling me, right, based on the knowledge that we learned so far, that this is only an access port. Let's make sure that is the case. Let's do a show interface, right? Show interface gigabit 0/0 switch port. Okay. All right. So just like we learned the last time, right? You know, how can we tell what this port is doing, right? What's its operational mode, right? Well, if we go ahead and go down here, it's going to tell us, hey, its operational mode is a static access. This is a access port. This is not a trunk. Okay. All right. This is the only thing we're worried about now. We also can see, right, that this port is in VLAN 1, which matches up to right here, right? What we have when we ran the show VLAN, right? So at this point, we can go ahead and summarize all the verification commands that we just used and say, right, VLAN tagging is not happening on this switch, right? We have a link to another switch, right? Because if we do a show CDP, right, or show LLDP, okay, LLDP is not enabled. But if I go ahead and enable it, let's do LLDP run. All right, and let me go ahead and do it on the other side. Right? They're going to go ahead and send LLDP frames, right, at layer 2. Right? And if I go to switch 1, now I can go ahead and say, oops, show LLDP neighbors, right? It shows me I have a neighborship with switch 2, right? It sees it, but it's only access port. It's not a trunk, right? So we want, right? Because the question that I asked you guys in this last lab is, can virtual PC, and let me get my pencil, can virtual PC 3 communicate with virtual PC 5, right? If I go ahead, right, and hop on these PCs, right? Let's go ahead and give it IP addresses. Let's bring it down here, right? Let's bring that up here. Let's do that. And let's open up PC 5. Let's bring it down there. Look, oops. Sorry, guys. Windows 11 is pissing me off. Let's go ahead and assign it an IP address, right? In that VLAN 10. So we saw VLAN 10 is 10.10.1.0/24. So let's go ahead and give it 10.10.1. Let's say 3. Okay. /24. And we'll do the gateway. Even though we don't have a gateway set, right? We'll get to that. We'll go ahead and give it a default being 1. Okay. All right. So of course you see it's checking for duplicate addresses, right? What you guys are going to learn about in the future is that it's doing this PC or this host or anything, printer, a Linux device, especially when you guys network, would do a GARP, a gratuitous ARP, to announce itself, right? To see, hey, I'm this IP address. Is anybody else this IP address? If they don't get no response, all right, cool. All right, I'm just letting you guys know I am this IP address on this broadcast domain. Okay. So of course, hosts, right, our PCs or what have you, if you guys didn't know, they have ARP tables, right? So they're gonna lock in that MAC address that ties to that IP address once it receives those GARPs or what have you. Okay. All right, let's do the same thing. Let's go ahead and put an IP address on PC 5, and then we'll test communication between PC 3 and PC 5. Okay. Let's go ahead and give it 10, whoopsies, 10.10.1.5/24. Hey, what's up, Twan? And we'll go ahead and do that. 1. Excellent. Okay. Speaking about ARP, let's take a side step, right? I told you guys that, and as you guys see me configuring, I configured a gateway. We don't have a layer 3 boundary, right? Or a layer 3 instance configured in this lab at all, right? Do I need that to communicate between each other? Absolutely not. Okay. As long as they're in the same broadcast domain. Okay, they're in the same broadcast domain. What's going to happen, and you guys are going to learn about this in the future, is that technology, that great technology that I love, right, that operates at 2.5, right, in the OSI model, is ARP, right? ARP is going to be used by our PCs to say, hey, who's 10.10.1.5? Send it to me, and then, right, send it to me, right, and send me their MAC address, right, and answer to this ARP. right? And of course, we're going to get our ARP reply and said, hey, I'm 10.10.1.3. Here's my MAC address, right? And then, right, the source is going to say, hey, I know the IP address and I know the MAC address. I can properly encapsulate, right, this packet that I want to send, right, so that it can go on the wire and be sent to its destination, right, because we're in the same local area network. Okay, so let's go ahead and test it. So we have, right, we have two PCs, both on VLAN 10. We have an inner switch connection. It is not a trunk, right? Let's see if this is going to work. So let's do ping 10.10.1.5. Okay, just as I expected, it didn't work. Why didn't it work? To keep it simple, right? We only have a link that's only carrying one VLAN, and that is VLAN 1. Okay? Okay? What happens if we do this? What happens if we go ahead and put gigabit 0/0 on both switches into VLAN 10? Let's see what happens. Let's see what happens to the communication between PC3 and PC5. Okay, we're going to go to the interface, right? Because we need to change the context. We'll do switch port, access, the VLAN 10. Okay, let's verify our work. Show VLAN. Oops, brief. All right, excellent. Right, so we went ahead, we confirmed this is in VLAN 10. Let's do the same thing on switch 2. Okay. All right. So let's do interface gigabit 0/0, right? Uh-oh, we see something, right? I got a syslog message, right? Level 4, right? So it's an alert, right? And a notification that's telling us, hey, we have a native VLAN mismatch. That's good, right? It's telling us, right? There's a difference here, right? Did we ever check on this switch if did we check our configuration, right? But also two, did we ever check if we had trunks here? No, we did not. So before we make any changes, right, I was going to jump in, so I do apologize about that, team. Let's check our configuration here. Okay, let's go through it. Let's go through it. All right. So I don't see trunk configuration. I do see ports, right, in VLAN 10 and VLAN 20. I see that here. Okay. All right. So we got that settled. Let's go ahead and verify our work. Let's go ahead and do show interface trunk. We don't have a trunk that exists. All right. So let's go ahead. Do a show VLAN brief just to be sure. Okay. Let's go ahead and modify interface gigabit 0/0. Okay. Whoopsies. There we go. All right. So let's add that to VLAN 10. So for access VLAN 10. Okay. All right. I'm still getting that error, right? But let's go ahead and do a show VLAN brief. Let's see what's happening. Okay. And let's check the interface status. Okay. Gigabit 0/0. And let's do switch port. Let's see the operational mode. Okay. Static access. So we're good to go. All right. So let's go ahead and let's check our communication again. See if it works. I'm getting pings. Gary, help me out. All right. Tell me why you think, right, communication is working between PC3 and PC5.
So both PC3 and PC5, now that we have a interswitch link configured for an access VLAN 10, that means we basically have extended our broadcast domain from PC3 to the PC5. So like a frame leaving from the PC3 going to the switch, it actually has no tagging on it. It just keeps the standard Ethernet frame, and that
Mm.
Ethernet frame leaves the gigabit 0/0 because switch knows it is good to carry the traffic for VLAN 10, so same broadcast domain,
Mhm.
and which was received at the switch 2. Or I
No, that's
or
excellent.
switch,
That's excellent.
yeah, yeah.
So,
And then switch 2 forwards the frame to the PC5, or vice versa. Actually, I did the other way.
yep, yep. So, Gary said two paramount things, right? Um, Gigabit 0/0, right? And the inner switch link is now on the same broadcast domain as the PCs. Okay, right? So that means, right? Remember, guys, chapter in part one of this book, I'm sorry, part two of this book, when you guys started learning about in chapter 4 is unknown unicast broadcasts. What happens with unknown unicast broadcasts? With unknown unicast broadcasts, the switch's job, right? And this ties with its three major functions. Its job is to forward, right? Broadcast frames out of all ports except for the port that it received the frame on. Okay? So PC3 said, hey, I'm trying to reach, right? If I do a ping, right, to PC5, hey, I'm trying to reach X, Y, and Z, right? That's a broadcast message, right? Right? The switch, since we're operating at layer 2, it doesn't know. It doesn't know. It doesn't speak layer 3 yet. It only speaks layer 2. So it's going to read layer 2. It's going to say, okay, this art message is a broadcast message. It's all Fs. I'm going to forward this out of all ports, okay, that are part of this broadcast domain, exactly like Gary said. Once it does that, anybody can respond to it, okay, as long as you're part of the broadcast domain. Now, let's make a point here. Since we proved all we had to do was just add the link to the same VLAN has the PCs, right? That communication is established. What happens if I try to reach out to PCs that are not part of this broadcast domain, like PC4 and PC6? Okay. We've talked about, right, in chapter 8, forwarding data between virtual LANs, right, or VLANs, right? If we want to go ahead and communicate between broadcast domains, we need a layer 3 instance. Okay? By default, right? If a switch is operating at layer 2, a switch is just going to forward data based on layer 2 logic. That is it. It's not forwarding data at layer 3. Okay? So if VLAN 10, let me get my pencil. If VLAN 10, right? All ports that are part of VLAN 10 are just going to receive that communication. Right? VLAN 20 is not going to receive communication for VLAN 10. Does that make sense? Okay.
Yes.
Okay.
Yes.
All right. So we have our different broadcast domains, right? If we want to go ahead and we want to have that we want to have communication between different broadcast domains, the literature says that we need a router. Okay? Router, aka a layer 3 instance, right? And what that's going to do is it's going to route those packets between the different, right? The different subnets, right? The different subnets, the different broadcast domains, the different VLANs, however we want to name it, right? Via layer 2 or layer 3. Okay. But it needs that layer 3 instance because the switch by default, if it's operating only at layer 2, it's only going to use that layer 2 logic. We need that layer 3 instance. Okay. All right. So we have switches here that can operate at multi layers, right? So it can operate at layer 2 and it can operate at layer 3. Okay. What we can do is we can go ahead and add a router to this topology. And we can say, hey, we'll connect switch 1 to maybe one port on the router, right? And connect it to, connect another switch to another one. And we can do it like that, right? But we have our switches here, right? And switches are now able to do layer 3 functions. Okay. So let's go ahead and let's see, right, how it works without a layer 3 instance configured, right? Let's go ahead and assign IP addresses to PC4 and PC6. Okay. So I'm going to go ahead, and I know I'm coming up on time, guys. I apologize. Um, I'm going to go ahead and pop up PC4 and PC6. Okay. Okay. There we go. Boom. All right. So let's give PC4 an IP address. Let's do 10.20.1, 10.20.1.4/24. And let's give a gateway 10 dot, whoops, 10 dot, whoops, 10 dot, if I could type, 1.1. Okay, it's going to do its guard response. All right, we're good to go. Let's do the same thing here, right? We're going to do an IP 10.20.1.6. Okay, let's do 24. Let's do 10.20.1.6. Okay, whoopsies, mistype. Sorry, guys. Okay, awesome. All right, now let's go ahead and test, right? Let's see if I can reach PC6 from PC4, right? 10.20.1.6. Okay, awesome. So we know why it's not working. It's not working because we currently have an inner switch link, right? That is in a specific VLAN, right? It's in VLAN 10, right? Right? We do a show interface gigabit 0/0/0 switch port. We can see that this switch port, right, is dedicated to VLAN 10. We can also even further confirm that this is dedicated only to VLAN 10. But with my topology, I want this, right? I want this link to be able to carry multiple broadcast domains, right? Multiple VLAN traffic. Okay? How do we do that? Right? We have to implement trunking. Okay? So we can do that by configuring a trunk manually, right? Or configuring a trunk dynamically, right? Using DTP, right? For this example, we're going to go ahead and configure this manually, okay? Let's go ahead and do it, right? So first, let's go ahead and go to the interface that's desired, right? Before we go ahead and make any changes and we say, hey, no switch port access VLAN, a good rule of thumb, which I've learned from a great mentor, is the most greatest thing you could do is, especially if you're in if you have hands on the switches that you want to change, um, and of course, they don't have layer 3 instances yet, and you're just consoled into them, it's better to go ahead and default the interfaces if you can. Okay. If not, make sure you have some redundancy in place and you properly test in a lab these changes, right? So for this lab, I'm changing it this way. In a real world environment, you would actually have to plan because, of course, maybe if you're doing this to a core switch, you probably don't want to default to interface. You probably would just, connect a different interface or what have you so you don't lose connection. Okay. So let's go ahead and do this. I'm going to go ahead and default the interface. And then I'm going to go ahead and get into the interface and I'm going to configure it as a trunk. So how do I do that? I'm going to do switch port mode trunk. Okay. Now, since this is old code, and I'm glad this syslog message popped up, since this is a old switch, we need to go ahead and change the encapsulation mode. So let's do switch port trunk encapsulation, and we need to say .1Q. Okay, awesome. Now we can go ahead and switch port mode trunk. And you only have to do this on the on this old code. Okay. If you're operating in a production environment right now, it's typically they would be on maybe Catalyst, 4Ks or 6Ks, mostly 9Ks, of course, if you guys are in an enterprise environment, because of course those are still in support, right? Cisco 9Ks, you don't need to put in .1Q. Okay. So just don't remember this command. This is just for this lab only. Okay, let's go ahead and do this. Save our configuration. Okay, let's go ahead and do this on the other side as well. And as we see, we are getting the native VLAN mismatch. That is expected because, of course, this side is not configured as a trunk yet. Let's go ahead and do that. Okay, so same thing. Let's default the interface just so we can make sure that it's clean. Okay. So we cleaned up the interface, right? Now let's go ahead and add that configuration. Okay, let's do switch port encapsulation. I'm sorry, switch port trunk encapsulation .1Q. Now switch port mode trunk. Excellent. Okay. All right. So let's check our configuration. Let's see what the trunk is doing, right? Let's clean up the terminal. There we go. Let's do switch. Let's do show interface trunk. Okay. All right. So let's do show VLAN brief. If I can spell brief. There we go. Okay, excellent. So what do we see here? Right? Let's dissect this command, right? Where our port that's a trunk is gigabit 0/0. The mode is on. Whenever we see the mode is on, that means we manually configured this trunk, right? The encapsulation, of course, is 802.1Q. We do have another option. We could have set ISL, which of course is Cisco proprietary. We went ahead and used the industry standard, IEEE 802.1Q. Okay. The status for this port is trunking. The native VLAN is VLAN 1. Okay. So we go to the next row, right? It says, hey, VLAN's allowed on this trunk. Well, we didn't make no exclusions or exceptions. So VLANs 1 through 4094 are allowed on this trunk, right? They're allowed to traverse this trunk. Okay. VLANs allowed and active in management domains, right? So it's telling us, hey, the VLANs that are allowed and the VLANs that we configured, right? And you guys are probably thinking, hey, but Dave, this said VLANs allowed on the trunk. It did, right? But this is just telling us the VLANs that's allowed and what we configured, right? Okay, that's where that management domain comes in, right? Of course, you see different VLANs right here, right? But these are on the switch by default. Okay. Um, this is just showing us what we configured and what's allowed on the trunk. Okay. Next row, of course, is telling us VLANs in spanning tree, forward state, and not proved. This is telling us that on this trunk, right? In terms of spanning tree, right? In terms of spanning tree for for these different broadcast domains, I am forwarding traffic for VLANs 10, 20, 1, or whatever the VLANs that we have configured. Okay. And the VLANs that I listed here, right? Traffic for these VLANs are not pruned, meaning I'm not blocking the switch, right? Or this interface from sending traffic for this. Okay. So with this configured, let's go ahead and save our configuration. Let's do it on the other side as well. Well, I already did it. OCD. Okay. Since this is configured now, should I be able to ping PC6 now from PC4? Let's give it a shot. Yes, I am. I'm able to ping it. Let's take a look of how that looks like. Okay. And let's go ahead and ping continuously to the other side as well. Okay. Let's do some packet capture. Okay. First things first, let's do gigabit 0/2, right? The incoming interface on switch 2 that connects to PC4. All right, just give me a second. All right, that took too long. All right, give it a second to pop up. Just give it a second. Okay. All right, let's refresh the page. All right, and let's try again. There we go. Sometimes a good old refresh does the trick. So let's look at gigabit Ethernet 0/2. Let's see what's happening. Okay. All right. So we see here, we see a few things, right? We see the traffic happening, right? And let's go ahead and pause it, right? Okay. Gary and Antoine, right? I want you guys to come off mute. Do we see any tags, any 802.1q markers at layer 2 incoming, right, on this interface?
We do not.
We do not. Okay, so this confirms the theory, right? This confirms what I've been telling you guys. Okay, one, a PC isn't going to assign itself, right, a VLAN tag. It's not going to do that. I mean, maybe a bad actor, right? Maybe a red teamer will go ahead and do that, right? But we're not going to do that. We don't have that here, right? And we're capturing on this interface. Okay, so ingressing, I don't have that. I don't have that here. Okay, let's go ahead and capture on gigabit 0/0, right? And this is our inner switch link, right? So since we configured a trunk, we should see, based on VLAN tagging concepts, we should see tags at layer 2, that 802.1q markers, right? We should see that. Let's go ahead and take a look. And oops, I see something. What do we see here?
We see a tag.
802.1q tag.
We see a VLAN tag, don't we?
Yes.
Does it make sense now what I've been trying to explain to you guys?
Yes.
Tagging is only going to happen on inner switch links, right? Whenever trunking is configured. If there is not a trunk configured, tagging will not happen. Does that make sense? And this is in terms of Cisco. We will have a lab where I explain tagged and untagged and hybrid and different interfaces like that. But just for now, does that make sense?
Yes.
Okay.
Yes.
Let's go ahead and further, right, our research, and let's go ahead and capture on the interfaces, right, that's hanging off of, right, that we're following this ping. Let's see if we see a tag going to the remote PC. Okay, so now I'm capturing on gigabit Ethernet 0/2 that's connecting to PC6. What do we see? Do we see any type of tags? The 802.1 tag that we saw before.
We are not seeing a
We do
tag.
not.
No.
Okay. Okay. So does it make sense as far as tagging? Tagging only happens. It only happens between an inner switch link that is configured as a trunk.
Yes.
Okay. Does that make sense?
Yeah, it does.
Okay. All right, guys. So let's go ahead and stop right here, right? Because we're getting up on the marker. I don't like the class to go over more than 30 minutes at a time. We'll go ahead and we will touch more on this, and we'll go ahead and jump to implementing a layer 3 instance, right, tomorrow. Okay.
All right.
All right,
Works for
guys.
me.
Later.
All right,
Take
take
care.
care, Dave. Thank you.